And greetings. Welcome to the Evidence and Reasons for the Christian Faith video channel. And I'm Salvador Cordova, and it's been a delight to share that music by Jack Trombey. I just found that video on the internet randomly, and the music was just so beautiful. It was set to football stuff, and so that was a tribute to Rebekah, who had we had this discussion about kind of the sports opening, and I said I need to make something kind of, probably not so edgy like the last sports opening. So,
Yeah, this is what happened. Sal told me, "Oh, Rebecca, you've got to use this for your premiere. You've got to use this sports opening." And I was like, "Okay." So I used the sports opening on my channel, like I think when we did it, and then or for something. And I was like, "Oh my gosh, this is the cheesiest opening ever. This is like, but Sal loves his sports opening. So anyway, thanks for doing that sports opening
oh
special
well,
for
you're
me,
welcome.
Sal.
And I couldn't help it. That disco music was just all right. So now you know kind of some of my musical tastes, classical and disco. So tonight I advertised this as Shooting the Breeze. We're going to try to do something less formal than the nerd torture sessions. I felt that it'd be good to have a break from that because that was really intense. For those of you who've joined um, who've joined our nerd torture sessions, thank you very much for suffering through that. That's giving you all a taste of what it's like to be a professional creationist researcher. I think most of you know who I am. I'm an independent molecular biophysics researcher, and I'm financed by all sorts of odd jobs, which I'm embarrassed to admit. And I had worked for a geneticist, world famous geneticist, for 7 years. I have 5 science degrees, and along the way, I had been an engineer and scientist in the aerospace and defense industry. So uh, that's part of, this channel tends to cater to Christians who are uh, science students, especially graduate students. Uh, they're PhD students that watch this channel, which I'm very honored that they would visit this channel and be edified. So we have to take things up to a higher level in terms of, believability, because stuff that you may hear on the internet, uh, it's different because for people like my audience, they're in classrooms all the time. They're studying under evolutionary biologists. They're studying under physicists who believe in the Big Bang and the mainstream views and about radiometric dating, which we're covering now. And I can't in good conscience just give them junk. And if something is not resolved, I have to tell them, okay, this problem's not resolved. You're not going to be able to paper over it. But my hope is to give them a little bit of encouragement that some of this science is not settled. And there's been a trend that I've seen in the 40 years or so that I've been watching the creation evolution debate unfold. Things that look like, a showstopper or the end of young Earth creationism, it would just get, one thing would just get overturned after another. And that trend has continued and is continuing to get strong. In my day, it seemed like the Big Bang was inevitable. I mean, is immutable. I'm sorry, immutable as a theory. And in fact, so much so that when I was sharing the Christian faith, I would use books like God and the Astronomers by Robert Jastrow. He was a um, he was a he was an agnostic, and yet he commented on the Big Bang. And there were great scientists involved in the formulation of the Big Bang. One of them, reluctantly, Albert Einstein. And I said, this is settled science. And you know, and then, like, the immutability of the speed of light. I said, well, okay, so the universe is definitely old, but it looks like there's been miracles of special creation along the way. So, and then there got to be more and more problems with evolutionary theory. despite all the hype that you hear, and I have a question I have to ask Rebekah briefly related to that. But as I
Okay.
saw this unfolding, the Big Bang started to fall apart. It's falling apart now. I could sense it when I was in graduate school in physics. And with the inflation model, that started to, Nobel Prize winner Roger Penrose and others now are questioning it. I'm just like, okay, yeah, the inflation model, galactic amounts of matter start to separate at speeds greater than the speed of light by factors of 1,000, a million, or who knows how much. And when I heard that in cosmology school, I said, well, okay, at this point, young Earth creationism isn't any more outrageous than anything else. And in fact, in the process of, because some people had complaints about inflationary theory, they began to put forward the idea of variable speed of light. And I'm like, wow, because that would solve the distant starlight problem, which is one of the big thorns in the side of young Earth creationism, the other being radiometric dating. And these are extremely difficult topics. I wanted to say that I often say this: intelligent design is easy. Young Earth creationism is brutally difficult. We've not solved all the problems, and we find it challenging. In
But you're saying what you noticed is that their models have the same types of problems, and so if they're going to be outrageous, what's wrong with our problems too?
I wouldn't say the same type, but the same magnitude of problems.
Mm-hmm.
And one wouldn't know that until one starts to study it in graduate school. And I'm just like, and you start to hear the whispers. So there were books by let me see if I have it handy. Well, I have some books handy. Oh, here, like my professor of supplementary quantum mechanics. These are known problems. And I'll just read you. Okay, so what am I going to do when I hear something like chapter 4 in James? My professor was named James Trefle. He wrote a popular book, and he said, we can summarize the modern view of the universe in two brief statements. First, the universe has been expanding ever since it was formed, and in the process, it has evolved from simple to complex structures. Where have we heard that before? Second, the visible matter in the universe is organized hierarchically. The stars are grouped into galaxies, galaxies into clusters, and clusters into superclusters. The problem we face is to understand how a universe whose evolution is dominated by the first statement could become one whose structure is described by the second. The problem of explaining the existence of galaxies has proved to be one of the thorniest in cosmology. By all rights, they shouldn't be there, yet there they sit. And that was his chapter, The 5 Reasons Galaxies Can't Exist.
Wow.
And these problems have not exactly minimized, especially now that some of our experiments in 2019 on dark matter, trying to detect it here on Earth with physical devices, and they determined, well, we can't detect it. If it exists, it's smaller than the electron. I'm just like, okay, or smaller than some subatomic particle. I'm sorry if I get some of those details. So that was one.
Wait, Sal, I want to ask a question about that. Now, I always hear them say, okay, because if I bring up dark matter, then they'll say, but the math works. We can't observe the dark matter, but the math works. So can you to me, what I'm hearing is, well, they need the dark matter to be there because of the because the galaxies shouldn't be like that. So they need the dark matter to be there. And so are they being circular? What's going on?
Yes, they're being circular.
Okay.
They're appealing to things that we can't directly test. And where, what's this is back in 2004 to 2000. So this is already almost 20 years ago. even then, there were 3 professors in my school, my undergrad alma mater. My undergrad was George Mason. My graduate was Johns Hopkins. My undergrad alma mater. So this professor was starting to point out problems like that. So he's kind of on board with the Big Bang, but he said there's problems. And he postulated dark matter as the solution. So that's the dark side of the universe. Dark matter is the solution. 3 of his colleagues at that same university, Minas Kafatos, Cicero Roy, Makibula Roy, I can't pronounce his name. They came out and said, those are absurd postulates. This whole thing is, this whole Big Bang thing is supported by untestable entities, variable, many loose parameters that you could just, in fudge factors like dark matter and inflation. And when I went to graduate school and I studied cosmology, it's like, you weren't kidding. I can understand your complaint. So let me see. Do I have my...
But when they say the math works, what are they saying there? Like, what is entailed in that? Like, are they saying that, well, it must be there because, like, our math works for the galaxy? Like, what are they actually saying?
Okay. If we assume the Big Bang and space is expanding, then to patch this up, it has to be dark matter. There's not enough I think there's not enough gravitational, there would not be enough gravitational attraction to synthesize galaxies together. It may even be stars. I don't know that for a fact. But the math will work if you put it there, if you put dark matter there. And I wanted to say, okay, if you put God into the equation, that'll work too. So at what point are you going to appeal to things that are untestable and unobservable? And there's some theories now that say, well, we're going to postulate a theory, and I may not get the details right, where this may be undetectable. I'm just like, okay. And there are all sorts of other problems. And the more I dug, I'm just like, there's this saying, there is cosmology and then there's speculation, as if to say, okay, there's something worse than speculation and we call it cosmology. It's not like what ends up happening is we tend to equate speculations of cosmology with down-to-earth physics. Down-to-earth physics is the physics that make our computers work, meaning we could test it. It's very predictable. We know we can measure stuff. Like we can measure electric fields. We can measure the current flowing through a circuit. We can measure voltage. We can't measure dark matter directly. We can't control it. That becomes very problematic if we can't ascertain some of its basic properties. Like we know with electricity, if you have electrons moving, we have an idea of the mass of the electron and its speed. When an electric field acts on it, it's like, what do we do with dark matter? We can't do those things. So like, when we have a lightning strike, we could say, oh, it has this many volts and the electrons in it have a certain amount of energy. And we can control that energy in the laboratory. If, instead of a lightning strike, we could do that. What do we do with dark matter that we can't even establish that it's there? And that's just one of the problems. The inflation one is just yet another problem. And I'm like, okay, how about we just have a big timeout? How about we stop shoving this down through academia and all the way down into the schools and say, okay, why don't we be a little bit more open about our problems and say, there's a chance we got this wrong and we may not know the answer. We say we don't know, I consider that more honest. So that's when I began to think. And then some of the stuff, even the last few weeks on radiometric dating, it's like there was stuff I did not know. So there were some things that I thought were very good criticisms against young Earth creationism, and some very good things about criticisms. And I want to salute Jordan K, Mr. Jetty 89, and John B. John B is a PhD
Mm-hmm.
geochemist, that he's professional at this. He's an old Earth believer. Jordan K is a nuclear engineer. And Mr. Jetty 89 works on a particle accelerator. Okay, so we got some brain power on the
Wow.
critic side here that's listening to me. And it's like, okay, Sal, um, you have to acknowledge, to be responsible, you give them a voice because given their qualifications. And if I say stupid stuff and I'm unwilling to acknowledge that I made a mistake, I'll look like the fool. And I'm not going to do that. And I have to thank them and say, okay, thank you for the correction. Thank you for teaching, helping
Mm-hmm.
me overcome my misunderstanding. So that was one. The other thing that's amazing, and before I went off to graduate school, is this book, Solar System Evolution.
Mm-hmm.
And it talked about the difficulty of evolving the solar system, something that I thought, oh, wow, it should be easy. You just need gravity, right? And it's way more complicated than that. There are, for one thing, all the planets have different chemistries, but what looks superficially easy, that there was like a supernova exploded, and other stars may have, or some nova, and it had all these elements in the periodic table that were created, and because there's gravity, they attract to each other and they're going to make a solar system. But when you actually start to resolve the orbital mechanics and classical mechanics, because the speeds involved are not relativistic, it starts to fall apart. So the first thing is, if matter's coming together, it's just going to make a ball. Why would it make a disk? Well, it needs angular momentum, where the gas cloud is basically spinning. It's like, where did this spin come from? All right, that's not insurmountable, but it's like, that's a data point. When it starts to come together, then yeah, it could form a disk. But once you have that disk or halo around the, like say the sun or the proto-sun, why should the disk become planets? That's, why doesn't it just stay a ring? Or worse, once the sun ignites, it's going to blow stuff off. It's going to blow away the gas. And this book here was written to fight creationism. I think if I can even read it, the author, who's a member of the U.S. National Academy of Sciences, Stuart Ross Taylor, he says, I'm sorry, I have to read this out of context a little bit, but I think you'll get where his heart is. This leaves the way open for salesmen of simplistic solutions that purport to explain everything in terms that a young child could follow. Of these, creationism in its various incarnations represents the most serious threat. The whole endeavor of science, and ultimately the very survival of our civilized society that has arisen from the study of the natural world in the past 4 centuries, is at risk. So he's saying, oh, if we start saying God did it, that's going to imperil science. And why that didn't resonate with me is I actually met more and more young Earth creationists who are very accomplished scientists. Probably one of the foremost right now is John Gideon Hartnett in Australia. He offered me to be his PhD student, or invited me. But, because of my situation, having to care for my mom, I couldn't go to Australia. Not to mention, I don't think I could drive on the left side of the road and from the right seat of a car. I think that would just be, I'd flown in the right, I tried to fly the airplane from the right seat, and it just felt too screwy for me. I said, I'll never be able to do that from, I'd like to learn how to fly the airplane from the right seat, but I said, oh boy, I can only imagine what it's like to drive on the left side of the road. So I know I've talked a lot, but really, this show is of a service to you. We can, if we decide to go off script because you have a pressing question, that's great. That's why I advertise this as Shooting the Breeze. So the question I wanted to ask, on your channel, I had argued against evolutionary theory, and Demeter came on and was just saying, this is so easy to refute. Has he ever Is he ever giving you a convincing argument to the contrary?
No, but I actually don't look at that channel very much, so he may have written some comments that I haven't seen. But uh yeah, I know that's frustrating when, you've got something that's really solid and then, somebody just comes on and says, "Oh, we've got that figured out." And then it frustrates you, doesn't it, when they don't like actually present, but they leave a comment like that.
Exactly. Or if they leave an answer that I know that I could totally see through. Um,
Yeah.
and it's like, okay, Demeter, if you want to say that I'm being deceptive, insinuate. I don't know that he used anything too harsh on me.
Hmm.
But it was just so funny. It's like, "Oh, Rebekah, you're being deceived by this guy." It's like, okay, you can, if it's that easy to refute, why don't you just state it in a few paragraphs and we'll be done with it? But then instead, you just make a comment like that and give the impression that you just didn't have time to explain it.
Hmm.
And, maybe you didn't have a good answer. I will point, however, to videos by by the Discovery Institute and the interview of my colleague, Dr. Joe DeWeese, uh, who is an associate professor at Hardeman University and an adjunct professor at Vanderbilt School of Medicine. He's a biochemist. And some of the arguments that I shared there, uh, that's on a topic he's researched for like 20 years professionally. He's focused on the topoisomerase enzyme. And it's like, okay, Demeter, you know, you might think that I'm easy to roll over. Here's someone that has studied the enzyme that I presented as evidenced against evolution, and he's in this for 20 years. He shares my views about the difficulty of this evolving, and uh, we have Dr. DeWeese's 1.25 hour interview after the animation was aired, and you could tell this guy really knows what he's talking about. So, um, you know, uh, now I don't want to be too harsh on Demeter. I want to thank him for criticizing my work, taking time to look and review it. There's a saying, it's better to be criticized than ignored. So thank you
Yeah.
to the critics. So,
Well, Sal, I wanted to, did you have somewhere you wanted to go with
no,
this?
I just want, no, I'm here at
Well,
your service. We're
I
shooting the
wanted
breeze, right?
I wanted you to summarize some of the things from Nerd Torture, because I watched a lot of your Nerd Torture, and I thought, I mean, I want to share some things that I learned from John B that I thought were interesting. But I also wanted to ask you, because you pulled up a lot of papers and you were very excited about them, but I wanted you to summarize in layman's terms what you were taking from those. And so I'll mention a couple of those things that you brought up, and then maybe you can tell me what's the takeaway. What did you get from that? But I can just mention from what was really cool is hearing John B talk about using the AMS machine, and like how you have to calibrate it, like with the for C14 is difficult, and you can correct me if I'm saying this wrong, but he said, like, when we're talking about some of the things that creationists have tested, like the diamonds, to see if they have C14. He said the problem with that is that you don't have any, like he said, we're like, even if you have an empty chamber, you can still get a C14 reading. And then with the problem with trying to do that with diamonds is that you actually, in order to calibrate the machine, because things won't be like, you have to have something that doesn't have, you would have to have a diamond that doesn't have C14 in it to calibrate the machine to see where the like proportions are, like, so you actually need something to calibrate it off of, because of like the sensitivity and because of the um, difficulties with the readings and stuff. So I don't know.
Okay.
I just thought
No. You got these essences of it right, and
mhm.
John B's credit, I want to acknowledge that he did raise valid concerns, and I suggested ways we could experiment with this. So the first thing is, and there were some things he pointed out, and I want to acknowledge, there could be a contamination of nitrogen. When you open things up and you're preparing it, if there's a little bit of nitrogen in your preparation, it could show up as carbon-14 because it has the same atomic mass of 14 nucleons, and it can show up. I said, thank you very much for that data point. So there may be some things that we definitely know, even outside of the sample, there could be contamination from the atmosphere or wherever. And I wanted to thank him for that. So it is entirely possible the diamonds might, okay, let's say hypothetically the diamonds don't have any carbon-14 in them. It's possible we're picking up nitrogen. And he also pointed out there's one other chemical called C1H2. I may get the exact one wrong. And I said, okay, thank you for that data point. And I said, okay, one way to resolve this is to synthesize a graphite, or the equivalent of a true blank. And I had made the suggestion, why don't we just collect the carbon that's going into the carbon-12 lane, where we have this accelerator mass spectrometer that is able to collect C12 in one lane, C13 in another, and C14 in another. I said, why don't you collect all the C12? I said, hypothetically. And now that may be technically infeasible right now. But I said, if we, the idea is, if the world really wanted to make a pure C12 graphite target, they could, then we could settle this. We could settle this. I said, okay, all right. So, what numbers are you willing to accept as valid? He said 50,000, anything that's 50,000 years. Beyond that would be hard. And I said, okay, so why don't we go, some of the fossils are registering. We have a few that are in the 34,000 year mark. And he said, well, it's probably contamination. I'd say, okay, now we have a conversation. And so Jordan Kay has been working on like the possibility of, radiation from uranium contaminating. And we're just working through that. And I'm arguing that maybe there's not contamination there. And so I think he made a good case that this may not be our gold standard as I'd been advocating. So that's a retraction there on my part.
What would be the gold standard that you're advocating that all of these
the carbon-14? Oh yeah, the carbon-14 in dinosaur bones.
Okay.
I'll say it's a data point. There might have to be other things that we appeal to, and that's fine. We'll just work through that. I did point out, I said, okay, so you'll reject certain ones that you don't like, but then you'll accept others that you like. And I said, I had to object. I said, I find that problematic. So if we use C14 to date human fossils or whatever, you'll accept those dates, wouldn't you? All right. So, I mean, hypothetically, if there were, like, say, a primate fossil that's 34,000 years, you're going to accept that date. But if it's a dinosaur, you're going to reject it. That's essentially what I was saying. And I'm like, okay, I have issues with that. And then we went on and on about the collagen in there. And he was just saying, oh, no, that's not collagen. And, it's nothing resembling collagen. And he caught me a little off guard. In the weeks thereafter, I said, well, you may have a breakdown of what it was, but if it's still the original carbon from the collagen, this is valid. And as I thought about it, I said, okay, there's at least a test in principle, because if we can sequence the collagen remnants, we know that this didn't come from bacteria because this doesn't exist in bacteria. That particular sequence, there's a spelling of the sequence. Even if it's fragments, you know that it doesn't come from bacteria. I actually went into the blast databases and started poking around. So I said, we could settle this in principle, that this really came from the dinosaur, because it certainly wouldn't come from bacteria. And I didn't have a chance to say, okay, we could settle this. It's going to be problematic. But then I hit him on, he said, we have all these independent lines of evidence that confirm this or that. And I said, you have all these other independent lines of evidence that say there's an error. And I pointed out specifically chemical decay. So we know when something dies, it starts to decay. There's bacteria involved in that, but even beyond that, there are all sorts of things that can cause the breakdown, even outside of the bacteria that would be involved in digesting and consuming, the host, the host organism that's being eaten. Like, for example, DNA has a half-life. We shouldn't find dinosaur DNA, but we have found, it looks at least like what they call chromatin. Chromatin's composed the DNA and histones and some other proteins. That's the other thing. Why should we find proteins at all? There's something called hydrolysis that should be breaking down the peptide bonds. We also find something called racemization. There's oxidation. There's any number of chemical dates that don't align with the radiometric dates. And I said, okay, that's a data point you should consider. So it's not a done deal by any stretch of the imagination. And then there's stuff like the faint young sun paradox. There's the erosion rates paradox. There are any number of things we could point out. And so what I would say is, I don't think either side, I'm kind of caught in between, where I will say, I don't think the young earth creationists have definitively proven their model, but I'll vociferously say neither has the old earth creationists or the old earth evolutionists. And neither side likes me saying that. But I wanted to say, for those who are kind of on the fence and might have been convinced that the old earth viewpoint was airtight, it's like, no, it's not. No, it's not. We have things also like the decaying magnetic field in the earth. That's a testable hypothesis in principle, meaning if the Lord tarries and we live a few thousand years from now, what if it starts to go extinct? We would know that'd be very good evidence the earth is young. By the way, there have been a lot of questions in the chat directed toward me, and I've seen it scrolling down. Sincere apologies, I haven't gotten to them. I'm going to invite my guest here, Rebekah. If she sees a question in the chat, she'll filter it for me and pass it on. Because I don't want it, this time was for her, and I don't want to rob her of that time as questions, if I address the questions in the side chat. So this is what I would suggest. If you want your question to get through to me, you have to sweet talk Rebekah into her posing the question back to me. How does that sound, Rebekah? Oh, I can't hear you.
Oh yeah, okay, that's great. Okay, sorry, I was muted. So, Sal, can I ask you about, and I will pay attention to the chat also, but so you brought up several papers in some of your nerd torture that you were all excited about. One of them was this one about photonuclear reactions in lightning. Now, can you give a summary in layman's terms why you were excited about this? What is the significance of this paper about photonuclear reactions in lightning?
Sure. So they have said you can't accelerate nuclear decay. There's a saying in the fighter pilot community, if you're not cheating, you're not trying. All right, so it's like, okay, let's accept that that's a rule. It's not hard and fast. People know we can accelerate nuclear decay a little bit, certain kinds, not all kinds. So if you do have a radioisotope and it has an established nuclear decay rate, half-life, I think the more proper term is like half-life. for many isotopes, you say it's immutable. And there, so the argument goes, if it's immutable, then it's a reliable clock. So let's say that's the rule.
Okay.
The reason I was excited about the lightning thing is you can cheat. So if you're not cheating, you're not trying. And I said, okay, let's see if we can cheat this. They're saying you can't change the rate. What you can do, though, is change the isotope. You don't have to decay it. You could just change it to something else, and that'll be almost as good. And so the young Earth creationist community right now, the overwhelming majority are advocating that somehow miraculously or naturalistically, and they're not in agreement how, that the nuclear decay rates isotropically, what we call universally. I don't know why they use the word isotropic. I guess that just sounds more sophisticated. If you want to impress the girl at the salad bar, that's what you say. The decay is universal. The formal term that they use is isotropic. So that means all across the universe, for some reason, the nuclear decays just got faster. They've invoked things like changes in the strong and weak nuclear force, which could blow apart the stars. I don't know, could do something really bad.
Okay.
And it causes, and this will be
the heat problem.
The heat problem. And
Okay.
I've actually said, hey, maybe your critics have a good point here. We creationists have a tendency that anytime the critics say something, we're just going to disagree reflexively. I'm like, that's maybe occasionally they get something right and God sent them there and you should listen to them. Just as an aside, Dr. Sanford sent me to learn about God's creation by studying under evolutionists, because he felt they would train me and teach me properly, even though we didn't have the same conclusions. He felt they had something that God wanted me to learn, and he paid out of his own pocket to have me taught by evolutionists about God's creation. So along those lines, when Erica said this is why young Earth creation is impossible, is if you have accelerated nuclear decay, it's going to incinerate the Earth. And Jordan pointed out that your blood would boil because of a certain potassium isotope in our body. If it accelerated nuclear decay, even a slice of bread would kill you, and your blood would boil during this accelerated decay process. And people say, show your references. Well, young Earth creationists were among, some dissenting young Earth creationists were among the first to point that out. So what ended up happening is the young Earth community, by and large, is kind of went, oh, that's the consensus model among young Earth creationists. So there had to be accelerated decay. But there was a minority like myself that was aware of this problem because of a minority of young Earth creationists. And I had to say, well, I think the evolutionists are right. We're just going to look like the fool if we keep advertising this and we can't explain accelerated nuclear decay. So back to your question about lightning. We don't have to accelerate nuclear decay. We can just change the isotopes. We were able to cheat. Now, that doesn't mean we're out of the woods, but I had presented a paper way back in about 10 years ago in my solid state physics class. I was trying to rescue my grade because everyone in my class were about equal in ability. So in one class, I'll be at the top of the class. The other class, I'll be at the bottom. This class, I was at the bottom. And I said, I want to save my grade. I don't want to get a C. I at least want to get a B. And I said, I'll do an outrageous topic that I think would glorify God by, working on the young Earth problem. I started to comb through all of the literature in the secular press, in the secular journals, that could show electricity could change nuclear structure, electricity and chemicals. And there was a paper in the 1980s that said lightning causes neutrons. And I said, that's a very thin, that's thin as a thread, as a lifeline for young Earth creationism. But I went with it. I said, that was published in the prestigious, the #1 scientific journal in the world. And that gave me hope. That started to lead toward my belief in young Earth creationism. And then in 2017, they had a more detailed study of the problem of lightning. They found that lightning created gamma rays, it created antimatter, it created neutrons, and it created new isotopes. And I'm like, yeah, this is what you want. You don't need necessarily nuclear decay. You just may need electricity in some fortuitous conditions, and you can change nuclear structure. And Erica's heat problem then is not as insurmountable as she has postulated. So that's why I was so excited, that I felt she made a very credible argument. And for a long time I said I think she's right. But the reason I got excited is I started to see all these electrical experiments in changing nuclear structure. There's something else to add. When there are earthquakes, the American Physical Society is now examining a phenomenon known as earthquake lights. It seems to be generating all sorts of strange electrically induced lights. And there are two effects that can create electricity with tectonic ability, at least in theory. We don't know exactly. One is the piezoelectric effect, where you compress a rock and it makes electricity. The other is the triboelectric effect, which we're more familiar with. On a dry winter day, as you're walking across the carpet, there's friction there. You develop an electrical charge. When you touch a knob like the one back there, you actually will release a 30,000 volt shock. Now, the reason it doesn't kill you is the quality of the electricity is high, meaning the voltage is high, but the quantity of electrons is not. So it doesn't kill you. If it had the 1 ampere that's going through your 100-watt light bulb, it probably would incinerate you. So I'm exaggerating about incinerating. It would probably be adequate to kill you.
Simplify it. Like, okay, so let's say this lightning is doing all this stuff, right? And changing the isotopes. So what does that mean for the rock they pick up out of the ground? And it's, got a uranium lead date of this or a potassium argon date of this. How does that lightning stuff change the how this rock is dated?
It means the assumption of how the isotopes got their proportions. So radiometric dating is in terms of what they call the parent the parent isotope, and then after it decays, it creates daughter isotopes.
Right.
It shows that the proportion, the ratio of isotopes may not be due to
decay,
radioactive decay at all.
But instead, the daughter element got there. It wasn't actually a daughter. It was like it was right there because of this transformation.
Electricity. Now,
yeah.
Okay, I gave you the simplified version. So if they're going to have a drinking game on me on Dapper's channel, I need to, by the way, I want to advertise Dapper Dino's channel. It's great stuff. Every creationist should watch at least one show of this where they lampoon a certain or several creationists. And I'm just like, okay, I don't always agree with everything they said, but occasionally they'll point out things that are wrong on our side. It's like, this is helpful feedback, guys. Don't make the same stupid arguments over and over again. And Dapper Dino will teach you that. What a kind thing to say. So, where I was headed with this is that it's more subtle than that. It has to do with how the isotopes originated to begin with. Because when we date rocks from the moon, we've had, yes, the moon landings were real. There are at least 2 Christians that attest to this because they were astronauts that walked on the moon. One of them, Charles Duke, influential to my return to Christianity. They brought rocks from the moon, and they used the comparison of parent and daughter isotopes and said this rock is 4 billion years old or something on that magnitude. I don't know the number off the top of my head. And then we have rocks like that here on Earth. Now, there were some Now Andrew Snelling and Dapper Dino has his issues with Andrew Snelling, but there was a moment that I think even the old Earth creationists would agree with Andrew Snelling. He sent off these he got some rocks, sent them off to radiometric labs, independently had them date using 3 different sets of isotopes. I don't know which one. This would be a good exercise for me to dig this up. And they all indicated that the rocks were, on the order of hundreds of millions or billions of years old. I don't know exactly what the figure was. However, each of the dating methods was off enough that it's like, well, this still demands an explanation more so than just experimental error. So this raises the question, where did the isotopes come from to begin with? Could they originate in supernova or, in the heart of stars? And supposedly if it's in a star, it has to explode so that it's released so that it can create things like the solar system. And this whole thing about electricity changing nuclear structure has suggested that there's a different method of how the isotopes are formed. Isotopes and all the elements. And that maybe the natural layout of all the isotopes is more in line with kind of giving the appearance of age, long ages. And that's why I was also excited. So there are 2 things. Lightning can hypothetically change, well, not lightning, but either small or even definitely large amounts of electricity through what they call a photonuclear process. And then it's questionable whether low amounts of electricity. So just to give you an idea, are we talking hundreds of millions of volts, tens of millions of volts, or even say a few 100,000 volts? And as I said, even your static electricity from a winter day is on the order of 30,000 volts. I cited an experiment that possibly changed nuclear structure, is published in the journal Science, and I think it needs to be replicated. Their voltage was only 30,000 volts, and they're able to change tungsten. What makes it possible is if you have not just the quality, which is the voltage, so to speak, but the quantity, which is the amount of current, the amperes, or the coulombs, amperes or coulombs per second. If you have enough current density, you might be able to cause what they call nuclear transmutation. Transmutation is taking one element and making it something else. And there are more and more experiments with this. The one that I was particularly amused by, it's by the IEEE, Institute of Electrical and Electronic Engineers. I was a member of the IEEE till I decided I didn't want to pay the dues. They've used piezoelectricity to make neutrons. And I'm totally exaggerating here, but it's like pounding on a rock and you're going to make neutrons. And neutrons can change nuclear structure. I was excited about that experiment. NASA has recently had an experiment with lattice-enabled nuclear reactions where they take electricity and strike a metal and it has some deuterium in it. They're able to do transmutations. And there are all sorts of transmutation experiments going on. So to summarize the nerd torture, especially this last Sunday, I was reviewing papers that are showing that electrons can be used to do what they call reducing the Coulomb barrier, and therefore you can have nuclear transmutations. And the young Earth creationists then have a way of getting out of the heat problem. So,
okay. Yeah, what was the thing you were saying? You pulled up one, transmutation of stable isotopes, and you were talking about Chernobyl and something that they were doing with that. Can you talk about that?
Sure.
Like, what were you excited about from that paper?
Okay, so this is all right. This is where,
but in layman's terms now. Don't get fancy.
Okay. First off, I'm sorry that this is long-winded, but this is a very, very technical topic, and I'm getting better at being more succinct. Like when we did our shows on abiogenesis and like the molecular machines, that was really a piece of cake because I could just show a cartoon and get the point across. This is much harder. Yeah. So can you ask your question again?
Well, you pulled up a paper in one of your nerd tortures. It was about the transmutation of stable isotopes. And so you were talking about that subject, and you were talking about something that was done with the material at Chernobyl. You were
Yes.
like, so what was it
Okay.
about that? Because it was a little bit complicated, and I didn't quite understand like what the takeaway was. The like for the young Earth creation view, or what it did for radiometric dating.
Okay. There was a request in the chat from Testament. I can't pronounce his name. Testament.
Okay,
And
can you link that?
yes,
Mm-hmm.
I'm going to type it here. I just typed it. This link is for you, Testament. That will take you to the video. In the video description are all the papers.
Mm-hmm.
Uh, and I did not specifically in that video description link to the paper where bacteria can change. It is postulated bacteria can change nuclear structure. Now, here in the US, that's outrageous. You'd be kicked off academia. The professor who put this out is the department head at the Taras Shevchenko University in Kiev, Ukraine. And he had taken, because he was successful in changing radioactive substances with bacteria, he threw the bacteria in Chernobyl and they were able to reduce some of the radioactivity. Now, in deference to my colleagues like John B. and Jordan K., they find those claims outrageous. Now, the researcher Vostovsky, I can't pronounce his name, he was invited to the annual meeting of the American Chemical Society in 2012. 2012. This is the other. There are two big prestigious organizations: the American Physical Society and the American Chemical Society. He was invited because he's a very respected researcher. We don't. The reason this is important is it shows if even bacteria can change nuclear structure, what else can be put on the table? How we Erica's very good point, and really Jordan's, the heat problem could incinerate the earth. I said, yeah, I actually agree with Erica on that. If you invoke what they call isotropic nuclear decay, but if you have low energy means of changing radioisotopes, this changes a lot of things. If even bacteria can change the proportion of parent and daughter products, this is a new game. So it could either be electricity, bacteria, or something else. And there have been other experiments and people have been skeptical. So why was I so excited this past Sunday? It was in a paragraph that actually explained the theory. And there was stuff in there I didn't know. If you can get electrons, I'll get just a little technical here. If you can get electrons to collapse into the nucleus, you can do all sorts of things. They gave a mechanism how that could possibly happen. Or you could get electrons to position themselves just right and change what they call the Coulomb barrier. You can change stuff. So bottom line, why was I excited about that Chernobyl thing? There's experimental evidence that bacteria might, and it's subject to claims. Jordan K. has a very skeptical view of this, but bacteria are claimed to change nuclear structure. And I said, okay, Jordan, you and I could argue over this, and I'm skeptical too. The way that this could be solved, obviously, is if we have experiments that can actually demonstrate that. They're not willing to do that here in the States, but they were willing to do it in Ukraine because they had a radiation problem. And I heard from Dr. Edmund Storms, who's a very respected nuclear physicist. He said Vostoysky was a hero in Ukraine. And obviously, if he's head of the radiological theoretical physics group at Taras Shevchenko University, he's bright, and I've read his papers. His math is just beautiful, and I was nerding out on it. So why was I excited? I'm like, this is such cool nerd stuff. So the bottom line, just to summarize, we're finding low energy evidence of low energy methods of changing proportions of parent and daughter isotopes. If that's the case, then the claims that you can't change radioactive decay, it's moot, because there's a way to cheat around that. And that's a big step forward. And also this is will have some implications for astrophysics and how the solar system came to be. So not to mention this is just really cool physics. So people know me as being like a big biology advocate. That's really not my natural, that's where the harvest was, but I love physics more. Did I sort of explain at least?
Yes, good. And then I guess the other one that you talked a lot about was the cold fusion. And you were like, people criticize this, but you were talking about something related to that. Is that the same type of stuff we've been talking about?
Yes.
Or is this another? Okay.
It's the same type. Whenever we can change it's basically changing nuclear structure and how feasible or infeasible. So it used to be the major way to change nuclear structure first naturally is like radioactive decay. That's one. Or you could make a hydrogen bomb. A hydrogen bomb uses, one part is a fission bomb, and that involves uranium or plutonium. And then the other part gets really heated up, that involves hydrogen or really deuterium. And basically you need lots and lots and lots of energy. Or you need a particle accelerator, these huge billion-dollar particle accelerators, super colliders, where you're just needing so much energy to make the reaction happen. And so they say, well, there's no way, radiometric dating is definitely the way to go, because short of the power of the sun and hundreds of millions of degrees, you're not going to change those isotopes. When we find evidence of ways to do it at low energy, so cold fusion is a way of saying low energy nuclear reaction. They're not exactly the same, okay? So for the formalist out there, they'll say, Sal, that's not exactly right. I will agree. But it's in the same ballpark. Rather than hundreds of millions of degrees and lots of energy, if we can affect nuclear structure changes, what we call transmutations, at low energy, that's good for young Earth creationism. Cold fusion is one mechanism of low energy nuclear reactions. It has a bad rap. And so the reason that I had a nerd torture session this past Sunday that was so long, I said, okay, this has such a bad rap of cold fusion, crank science. I started reviewing accepted peer-reviewed papers on journals like Nature and say, okay, the popular press will represent this as crank science, but you'll actually see these things that are appearing now in peer review. And what they have done is they don't call it cold fusion. They don't call it anything. They'll just say, oh, we've affected this reaction. We're detecting neutrons and we're getting these elements. They do not want to use the word cold fusion, but that's what some of this really is. And it's happening at lower and lower energies. And there are a variety of mechanisms like, or even high energies, but then you have something like lightning. Lightning would be kind of classified as high energy. Mm-hmm. So we can change nuclear structure without hundreds of millions of degrees. You just need a lightning strike. So it's still high energy.
Okay, but now this brings up the question, but just because we can, and just because it's possible, does that solve the problem? Like, because to me, it's like, okay, you can, but is that really the explanation for why things are the way they are?
No.
And okay.
Short answer, no. It gives us
And
hope.
then,
Let
okay.
me just say, you know what I've been saying? I said, so it's acceptable for the abiogenesis and evolutionary community to say, oh, maybe that's a problem we're working on, but everything
Right.
else says it's true. So you should accept it. I'm like, okay, so then if the young earth creationists also say, well, we're working on it too, how come how come it's a different standard applied?
Right.
And so, my
Yeah.
response is, I think there's a better chance that we'll have more progress on the young earth creation radiometric problem than we will have on abiogenesis. Because at this point, I'm seeing papers now, it's become fashionable to invoke multiple universes. Prior to that, they were invoking extraterrestrials. Okay. So I knew everyone was kind of like saying that's pretty bad for the abiogenesis community. That's how poor the progress has been. And that's why I
Mhm.
believe it was act of special creation. However, I've seen the young earth creationists go from like impossible. Now we're starting to see maybe an avenue that this could happen. So I think it's, if someone wants to be skeptical and say we don't know and I'm not going to make a decision, I think that's fine. But for me, there's been so much evidence in favor of creation in general, that even a glimmer of hope is enough to say, I think there's an acquittal here. There's enough
Mhm.
reasonable doubt to say, I'm not going to imprison this idea and just discard it.
Yeah.
Let it have the freedom to be explored.
Now, Jesus Garcia had a question. He said, so bacteria eats radiation. And so is that something that you're comfortable saying, yes, that's true? Or is it, are you still with, because of this, these things that have been done in Ukraine? Or is it still something that you're saying, well, it looks like it might be true?
I put it in the might be category. But Vostosky has also worked on other experiments. Okay, I'll tell you, I would have definitely written it off 20 years ago, 30 years ago as crank. But when you saw me excited the last few weeks, we've come down from the other end of, the bacteria changing radioisotopes. It doesn't really eat the radiation, it eats the isotopes and changes them. What we have seen is we've gone from like needing hundreds of millions of degrees, the temperature of the sun, down to lightning level, which is less energy. And then I'm finding experiments with lower and lower levels of voltage involved. And we're beginning to understand some of the mechanisms of the electrons um, doing what they call electron screening or collapsing into the nucleus. There are conditions where you can collapse the electrons into the nucleus. When you can do that, you make it neutral, it can interact, you can change matter. So that gave me hope that maybe bacteria has figured out a way, so to speak, or God figured it out how to make bacteria that can arrange the electrons in the right way such that you get either electron nuclear collapse, or you get these electron quasi particles, which is another topic. But if that happens, then you can change nuclear structure. So for those of you who watched the James Tour Theory series when he was bashing Dave Farina, that was one of the most beautiful things I've ever seen on the internet. Glorious. I'm sorry. um, he talked about quantum spin, chiral induced quantum spin, something like that, where you can control even the spin of the electron. When I was studying biochemistry, plants create quasi-particles called excitons. There are all sorts of quasi-particles in condensed matter physics. Magnons, polarons, uh, electron holes, heavy electron quasi-particles. In the condensed matter state, if that bacteria can move those electrons around in just the right way, they might be able to change nuclear structure. That's why I was excited reading those papers. Something that seemed impossible, ridiculous, outrageous, crank people, when we examine actually orthodox theory, it's like there was a solution there that you didn't consider. And it's there in the equations. We don't have to invoke new laws of physics. We found loopholes. So just like in human affairs, we think of all these laws, and some clever lawyer finds a loophole for you. We found a loophole that bacteria might be exploiting to change nuclear structure. And I was just like, oh wow, this is so exciting. And that's a good thing. It kind of gets my mind off girls. That's another story. We won't talk about that. You know, Rebecca's kind of privy to some personal things in my life. But anyway, that's why she's smiling. Um, the yeah, see, I can't think straight now that I said that. I can't get back to nuclear physics. But it's exciting area of nuclear physics where we may have found a loophole. We don't have to change the laws of physics, but the laws themselves may provide a loophole for us. The bacteria may be using that. And that's why I was excited, because now it could become mainstream at some point. And if it becomes mainstream, this whole thing about radiometric dating, it's going to be a big reset for a start. It may not prove young Earth creationism, but now we no longer feel like the battle's just totally lost. We definitely have more than a fighting chance.
Okay. Jesus Garcia said, why wouldn't the government in Ukraine do experiments to confirm any of this research? Wouldn't it help Chernobyl?
I think, this is what's kind of sad. I would like to have conversations. And Mr. Jetty 89 said, why don't you write the researchers? There's some researchers here stateside. And I said, that's common sense. I have nothing to lose. There's a saying, you miss 100% of the shots you don't take. There's nothing stopping me from trying to contact some of the researchers who know Vostochny. I can contact them here in the United States. Maybe not that they write back, but I can try, nothing to lose. So the question by Jesus Garcia is, why doesn't the government support this? I actually think the government has. I think the government in Ukraine has. Vostochny's a hero there, from what I hear from American researchers. So I think a responsible reporter would try to gather this up to see if he's gotten government funding for this. He's a very respected professor. I can tell that by his publication list and the number of co-authors he has, even some from Russia in Moscow. So he's internationally recognized. And then he impressed a lot of scientists here in the United States. I can tell you as a student of physics, as I read his papers on this quantum nuclear attraction, I was like, this guy's good. He knows his nuclear physics. He knows his quantum mechanics. And like, he's not a BS artist. This is, to understand his writings, you got to be good, even just to understand it or critique it. If you're going to disagree, you have to have a lot of knowledge. And I'm just like, yeah, this is impressive stuff. I started going into the papers that were written in Russian. I had to use Google Translate to read it. So I think he's legit. I think the government has invested in him, and these experiments have gotten some money there in Ukraine. They had a staff of I think 100 people running the experiments. So if you go to the link that I provided earlier for Testament to my Sunday show, the Nerd Torture Session, where I talked about Proton 21 and exploding wires, that one. If you go to that link, you'll see the picture. That's the Proton 21 device where they're using electricity to create isotopes all across the periodic table, which is just unbelievable if it's true. That device is called Proton 21. They rebuilt one like this with American scientists that's more powerful, called Thunderbird. It's in Tennessee. And so there's money. And I think some of these experiments have actually quietly gotten government grants through the Navy's, through either the Department of Energy, NASA, or Naval Space Warfare. Naval space warfare has actually done stuff on cold fusion. So there's quietly money there, but they're being, they're deliberately trying not to use certain terms like cold fusion because it has a bad connotation. But there's a lot of that. So the fashionable term is condensed matter nuclear reactions. And
Okay.
yeah, so short answer, there is government funding even in the United States. It's just not talked about because if it gets too much attention, the critics who are fighting for the pie of money will try to kill the project. So these guys have been able to sneak in government grants. So it's there, not a lot.
Cool. So I wanted to ask you about what I've heard you explain this before. I think I may have understood it, but I just want to ask again because I've heard you bring it up a few times. What is the deal with what you're saying about there's too much uranium on the continent and not enough on the seafloor? Can you explain why this is why is this a big deal?
I'm trying to think how to simplify it. Okay, so let's say that the mainstream, okay, I'm sorry if I'm going to be long-winded because it actually takes a lot more thought to be succinct. So I may wander around. The idea is the solar system came from the remnants of a supernova. Mm-hmm. And what would end up, how could you get, let's say there was uranium floating around in the remnants of that, in that nebula that made the solar system. Well, it's just like when if you're trying to add like food coloring to water and you mix it up, it starts to even out. The thought is it's kind of the same in that nebula. The uranium would have evened out in that mix, and when the Earth came together, it ought to be about the same throughout that ball. Now, it may either float up or down. Uranium is heavy. It would tend to float down. If it oxidizes, it may or may not float up. But you'd still expect it to be evenly distributed. That's basically it. Why is it not distributed? That's a problem. What if, okay, now I'll invoke some young Earth creationism. What if pounding rocks together starts to create uranium? This would suggest then Noah's flood may have created certain uranium isotopes. And Jordan K. will cite Oklo. The young Earth creationists have contested the interpretation of Oklo. I've not had a chance to review it. Just to be responsible
here. What is Oklo?
Oh, I'm sorry. They'll say that there was a natural nuclear reactor somewhere on the world where there was enough uranium, and that's proof that of all sorts of things. And because Jordan's a nuclear engineer, we have to respect his opinion on that. But on the other hand, I have to say not every young Earth creationist will interpret it the way he does. So going back to the uranium on the continental crust, the references I've tried to put in some of my video descriptions. I don't know if I put it in my last Sunday night show, but other shows I have. The World Nuclear Organization says we have 70 times more uranium on the continents than on the seafloor or inside the Earth. So they've had a variety of theories to explain that. So they have the sprinkling theory that says, well, there was not so much uranium in the original nebula, but then somehow it just wandered into our solar system, created a ring around Earth. And it may even be in this book, by the way, that talks about it. And this ring started sprinkling uranium on top of the Earth. I'm like, okay, that'll explain why it's on the surface then, but then why is it specifically on the continental crust and not on the seafloor? And then, the geologists may come with some alternative explanation. But it's still problematic. What if the best explanation is that all the tectonic activity in the fashionable view in the young Earth community is that the continents were moving around fast as in 40 miles an hour, which would be, you'd be able to get like Europe to, you know, you'd be able, you know, where the Americas and Europe were kind of connected, and then they split, and you know, after a few months they're separated. That's, or however 40 miles an hour would get you there. Might even be just a matter of weeks. And so these things are moving, they're colliding, creating friction, generating lots of electricity that might create uranium. This experiment in the Ukraine was able to create uranium by hitting copper with electricity. And I reviewed that experiment in detail. And so a minority of young Earth creationists, definitely not the majority, minority of young Earth creationists, pioneered by Walter Brown, God bless him, has postulated that all the electricity generated by the tectonic activity was able to create uranium like the experiment in the Ukraine in the Proton 21 laboratory. And there's a benefit. It's what they call, it's a net adiabatic process. It doesn't add heat in the process of these fusion reactions. The fusion reaction doesn't add heat or anything substantial. And I started laughing at the end of my show. I said, "Hey, Wesley, look at that. There's no heat problem." And he got it instantly. So that heat problem that Erica articulated, and I think it kind of got you by the side, I was happy for you when I read that. I said, here we have an out. We can actually change nuclear structure, and it's adiabatic, which is a fancy way of saying it doesn't generate heat. There's a formalism for what adiabatic actually means. I think it means you don't add or subtract heat from the system. I think it's proper to say it's net adiabatic. You may need some heat because obviously lightning has heat associated with it, but you're not generating excess heat, or not substantial amounts, by these fusion reactions. So one, we might be able to account for the isotope ratios. We don't have to invoke accelerated nuclear decay. We don't have to, which would be new laws of physics, which I'd rather we not do. And we don't have the heat problem. And that's why I was very excited. And I have to admit, okay, airing a little dirty laundry among creationists, just like secular scientists, a lot of us, myself included, are stuck to dogmas, and they'll defend it. So even within the young Earth community, what I had articulated is not well received. It's not well received. It's received by a minority, but not by the majority. So, oh, by the way, I may be speaking at the Creation Research Conference in July, if they will accept my abstracts, chance to meet me. And the Creation Research Society, a lot of the members would not agree with me. So just take it, caveat emptor, and I could be wrong too. And I've had to make retractions, but I do think this is probably the path to go at this stage of the game, given what I know.
Okay. Cool. Well, like I just started seeing some of the questions that came up before. And now they're kind of moving where I'm having a hard time keeping up.
Yeah. And if I could explain to the viewers what's going on.
Yeah.
In our dashboard here on the Restream platform, it's very hard to scroll back to older comments. It can be done, but it's a pain. There's a scroll button there, and you can't see it, unfortunately, where you could scroll. And if you tell me the comment, maybe I can.
Well, no, well, the one that just came in, and I'm not looking on Restream because it was like delaying the comments like by an hour. Okay. So I just started getting comments from like an hour ago. But Jesus Garcia, why do I get it? Probably Jesus. What are the best scientific books that support YEC or any good resources?
In the beginning, go to creationscience.com. You get a free book, Walter Brown. He was very instrumental in my transformation from an old earth creationist to a young earth creationist. It's also it's a very good basic anti-evolution book. So even if you come away as an old earth creationist after reading it, it had a lot of good old earth creationism in it. He got his PhD from MIT in 2 years in mechanical engineering, which is a miracle. He's a very brilliant man. I loved his way of thinking, and he gave data points that you won't hear a lot in the young earth community, in things that I think a responsible creationist should let you know, like the fact that certain meteorites here have been opened up and they have earthbound bacteria that a lot of scientists vigorously, including scientists at my undergrad alma mater, Robert Hazen, who insist these were existent in the meteor. And this raises an interesting question. Did the meteors come from an explosion that was earthbound? That would seem to be the best explanation. Not to mention the bacteria don't look evolved compared to the bacteria we have here today. And that's another evidence of the clocks look wrong to me. There are supposedly 200 million year old bacteria that look modern. That shouldn't be the case, that were trapped in salt or amber. And of course, the evolutionists will say, well, that's obviously contamination. I'm just like, okay, this bothers me. When the data point doesn't agree with your narrative, it's a mistake. Rather than you thinking maybe your narrative is the mistake, maybe the data is right. And, this is going to go back and forth, I expect. So back to Jesus's question, those are the data points you'll get from creation.com. You'll get a perspective that is not mainstream young earth creationism, but I think it's better than mainstream. It's a minority of a minority viewpoint, but I thought it was really good stuff. It's easy to read. It's easier to read than listening to me. And there are also videos associated with it. Another resource, if you Google Brian Nichol, I'm typing it in, origin of the Earth's radioactivity. There are some objections that I think would be legitimate against that, but it's a good start. And it highlights the work of the Proton 21 laboratory. Up until this past Sunday, before I got a hold of the original papers written in Russian, and I had to go through a painful process of translating it because I don't read Russian, I was like, yeah, I'm kind of ambivalent. But when I actually saw the theory and found the loopholes in the laws of physics, what they call nuclear electron collapse, I'm like, okay, now I'm believing you. And in fact, it motivated me so much that I'm going to write these guys and say, why don't we do some exploding wire experiments? I think this would be interesting. Can you tell me how to do this? One of the scientists involved is George Miley, who's at University Urbana-Champaign, retired emeritus or retired. University of Illinois, Urbana-Champaign. I actually thought about getting my PhD in physics from University of Illinois, Urbana-Champaign, because they're friendly to the work of Ukraine. So, just learned Russian. It's easy. Нет. I know one other word in Russian. Vodka.
Cool. Well, have I tired you out, Sal? Are you ready for bed?
Unless, maybe we could just collect the questions and we could just have another show. I think it's good we don't just wear out our audience too and want them coming back for more. So I can meet you backstage. I'm going to, if you'll indulge me, I'd like to play the sports music one more time and then I can meet you backstage. That's just kind of a nice way to end. Would that is that okay with you?
Great. Thanks for being here, everyone.
So if you had some closing words while I get the music set up. Uh,
Yeah, well, I just thank the people that are here right now. Dapper Dino, Greenie, Testament, and Jesus. I'm sorry I was saying Jesus. I was butchering your name. I'm sorry. And Stephanie, thanks for being here.
do you see anyone from? Can you tell me about your channels? Were you on another show earlier?
I was on Gur streams earlier.
Oh,
So,
that's why they were giving you a hard time.
oh, were they? What did they say?
I don't know, about something about an after show or something, or
Oh no, that's yeah, Jamie Russell's doing an after show for standing for the debate that was on Standing for Truth. So that has nothing to do with me, but I will probably go over there and say hi if he's doing the after show right now. So
okay. So I'll meet you backstage after. I just want to end on
sounds
a
good.
beautiful, happy note here with the sports music. So I'm going to mute both our mics, and we'll just close out with this. And God bless everyone in the name of our Lord and Savior Jesus Christ.